Hey there, this is Christopher talking. Welcome back to my channel. Today I'll be introducing you guys with the new concept, quantum numbers and energy level diagram. So before we start, there are a few things we have to know. So three key terms, which are alpha bell principle, Pauli exclusion principle, and the Hund's rules. First thing first, we have alpha bell principle, which is the alpha-bell principle, which is the theory that an atom is built up by the addition of electrons. So let's say, for example, we have 1s, 2s, 2p, and 3s, 3p, and then there's this 3d, 4s, 4p, and then 4d, 4f. This is the alphabet rules. Um, Basically, what you see right here, it usually goes like here, there, here, somewhere over here, and here. So this is basically what explains the alpha bell principle. So from here, we're going from the tail to the arrow point, which is from the small less electrons to the most electrons. So 1s is the least electrons they have, possibly have. And then moving on, we have the 2s, 2p, 3s, and then 3p, 4s, and then we have the 3d. Notice that when you turn from 4s into 3d, there's a little difference. Well, which you can see here, 3D has more electrons than the 4s, and then later it comes to 4p, and so on and so forth. This basically this tells you the electrons, which one's larger and which one's smaller, right? It has less electrons. Next, moving up, we have the Pauli exclusion principle. The Pauli exclusion principle is basically an orbital can hold two electrons with opposite spins. Let me show you. Let me give you a little visuals so you can see what's going on. This is basically what we call the opposite spins. Think about spins as like an arrow. This is what we call the opposite spins with an S, of course. And later we'll be introducing you with an example based on the Pauli exclusion principle as well. So see how it looks like. Lastly, we have the Hund's rules, which is basically electrons filled with their subshells singly before forming any new pairs, and each electrons in a single occupied orbitals have the same spin. So let's take a look at first two examples that we have. Let's say we have lithium. Lithium on periodic table. So lithium is basically, it has, what is the atomic number? What is the protons of that? Lithium, well, of course, it has 3. So 3, let's say, on a graph, this is how you normally draw this. There's actually two ways you can draw this, but normally the first one is more recommended. We usually go like here, here, and here. This is what I mentioned. The electrons fill their subshells singly before forming any pairs. So pairs looks like this, but you have to make sure every single boxes has a single subshell. Or some people might do it like this, this, or this. Still correct. Basically the same thing, but your works the other way around. for some people who are tentatively special. And there are two ways that people might be confusing of. But when I introducing with a new concept, you will basically get the understanding. And some people might be doing like this or that, which is wrong, totally wrong. And this is really important when it comes to drawing, because you have to make sure everything has a box that has the subshells. You have to fill the subshells first of all. Where some people go like up and then down, which is also wrong. Those two ways kind of violates the Hans rules. Now, let me show you an example based on what we just learned. It's tungsten W. 74 electrons. So let's draw this. One S has one. Oh, sorry. So this should go like that. 1, 2, 3. Then 1, 2. Sorry. See, this is how you properly use the rules that we just learned. And that's up to 4p. So 4p, what we have over here is basically full shells as well. But we have to follow the Hans rules, which every single box has to have fits the subshells. And then there's the 5D, 4D, full shells again, and then up to 4, 5p. Success. 4F, it's also full shells as well. And then lastly, we have the 5D. And and that's the end of the tungsten. So later, now we're gonna count if we get it right or not. So this is a 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 1, 2, 3, 4. So 74 electrons in total for tungsten. And that's the end of the video. Thank you guys for watching, and hope to see you next time. Bye.